Welcome everybody. Hello, hello, welcome. I hope you arrived well and had time to have a coffee and some breakfast. Hello, my name is Martin Humenberger. I'm your host today. I'm the scientific director of NAVER Europe, and we are organizing now our workshop on AI for robotics for the 4th time. And there are two like novelties this year. First of number one, we have for the first time we have T-shirts. I hope everybody got one and you will like them. Second is a bit sad because we were not able to host all of you at our premises at NAVER Europe because our big room is under renovation. So that's why we are here at Koloft. But it has a bright side. We can host more people. So I'm very happy to see such a full room here, and I hope everybody will enjoy this. Speaking of which, welcome to France for all of you who came from abroad, and of course, welcome to all our dearest speakers and poster presenters that accepted to be part of this workshop. We have a quite nice and packed agenda in 2 days, and what I won't go through all of this now, but I would like to highlight that at the end of the first day, today we will have our social event. This time it's not in a restaurant, but it is actually at our premises at NAVER Europe, where we'll have not only cocktails and dinner, but also tech demos. So you will see 3 tech demos, and I will briefly introduce the technology now during this presentation, what you're about to see, but much more details you will learn about during these demos. On the second day, we will have our post session. It will be at 11 o'clock here also, and we will hopefully finish the workshop on time around 5 o'clock. I would like to thank all of my co-organizers for all their work to make this and all the past editions happen, and of course the people a bit in the background that organized all the logistics. I think many of you had the pleasure to exchange with Hasna, who organized all the logistics around this event. So thanks to all of you who helped making that happen. Some practical information. So there is Wi-Fi. Here you will find the code. We will record the sessions. We will not record the Q&A session. And if you don't want to be on any of those recordings or photos, then you should have a red lanyard, and then please sit on the very comfortable seats at the back of the room. Some organizational information about the tech demos. So we are a bit limited in space at our premises, so that's why we organized our demos in 3 rotating groups. And on your badge, you're supposed to have a colored dot that tells you in which group you are. And each group will have a guide when we are there in our premises, and this guide will guide you through the three demos. This is how we are organizing our demos tonight. And don't worry, at every demo there's also food and drinks. So much about the organizational things, and now I would like to introduce a bit NAVER and NAVER Europe so that you know who is organizing this and why we do that. NAVER is Korea's #1 internet company, and basically the Korean people use NAVER as their daily platform to do all kinds of things, mainly internet search, information retrieval, e-commerce, shopping, fintech, meaning payments, but also you can handle all your, a big part of your financial affairs with NAVER platforms. NAVER is also very big in entertainment and content creation, and on a more business-oriented side, it has a very important cloud business. And cloud is important for us as NAVER Europe because that's where the AI part is embedded. NAVER Labs is in fact the research branch of NAVER, and NAVER Labs is in charge of creating the future of NAVER, preparing NAVER for the future, in particular when it comes to robotics. And I will introduce a little bit NAVER Labs. However, we have later today Dongwan Lee as a speaker from NAVER Labs, and he will present you much more details and much more technical stuff around what NAVER Labs is doing. Yet, I would like to show you this little highlight video to give you a glimpse about our tech. So during this video, you saw a couple of times these robots here, and these are our delivery robots, indoor delivery robots, and they are currently operating in NAVER's headquarters building, which is called 1784, and this is Korea's first robot-friendly building. This is a building that was constructed from scratch in order to host robots, to enable people to benefit from robotic delivery services. In particular, you can order your coffee, food, you can get your packages delivered to your desk, you can buy something from the in-house convenience store, and you can even send packages from one desk to another. And that's actually the last service is the one we will actually demonstrate to you this evening during the demo session. So, but now let's talk about NAVER Labs Europe. So we are the European research hub of NAVER Labs, and we are working on AI. Our mission is advancing AI to make NAVER's service robots versatile and useful assistants. And our vision is we want to have useful robots in everyday life. So what does that mean, and why don't we have them yet? This is what I want to talk about now. So if you consider the capabilities that robots have today, you have on the one end of the spectrum, robots that are able to execute simple tasks in quite uncontrolled environments, such as this little vacuum cleaning robot in our homes. On the other end of the spectrum, you have robots that can execute very complex tasks in very controlled environments, such as those industrial robots manufacturing cars in a factory. So the challenge comes, what if you want to have complex tasks in very uncontrolled environments, such here? Then, well, often it doesn't work so well because it's very hard to make robots do actually complex tasks completely autonomously. And sometimes it's even not safe. And here we see what happens, and even the poor robot doesn't know what's going on. So how can you, that's how we see the current situation, and we asked ourselves the question, how can we move towards versatile robot capabilities? And we look, one way of answering these questions is actually looking at foundation models, such as we all know from the digital world. Here we have a conversational AI that can remarkable things, does exactly what every user wants it to do. It's trained with massive data, with videos, text, and it had a lot of success in the digital world. And we thought, what about using foundation models in the physical world? Also training that with massive amounts of data, but relevant for tasks in the physical world. And that might be the way of making robots actually being able to do such complex tasks in uncontrolled environments. Like just some examples, doing laundry, last mile delivery, or much more user-centered tasks like a robot guiding people around, explaining stuff. But eventually that's not, these three tasks are just examples. What we want is a versatile robot, so that the user can decide what the robot should do, and not the other way around. So robots have to be intuitive and easy to program and easy to deploy, so that the long tail of user needs can actually be fulfilled by such a robot. And well, that's why our research is centered around AI for robotics, and in particular around foundation models for the physical world. And we go along three paths. First, we want to create new foundation models that do not exist yet, that are yet able to solve relevant problems for this robotic endeavor. We want to improve existing foundation models so that they can be used in AI for robotics. And also we tackle the challenges of deploying such models in the real world. And then hopefully, when we combine all this, we will be able to execute our complex tasks in uncontrolled environments with much more success, and of course also safe. And I hope that now the user is happy. Yes, he's. So AI and foundation models, that's our path towards making our vision come true, which is useful robots in everyday life. Okay, a bit more concrete when it comes to research. So we conduct these foundation models for the physical world and AI for robotics research along three primary directions. To achieve this, we thought like a robot basically has to have three main capabilities. It has to understand what's going on in the environment. It has to be able to actually take actions. And as the robot, that we are not a world only full of robots, it also has to be able to interact efficiently with people. And I would like now to show you some examples about each of these directions. And actually, everything I talk about, you will see in much more details during the tech demo tonight. So let's start with making the robot understanding efficiently and correctly what's going on around it. And for this, fully compliant with our strategy foundation models, we decided a couple of years ago to build a foundation model or a family of foundation models for 3D vision, to understand what, to make the model understand what is going on in the world in 3D, so that robots can use it. And the first version was called Duster, and this is basically a toolbox that enables to solve many 3D vision tasks, all powered by one model. We extended this because we saw that matching capabilities and metric scale are important to enable new tasks such as map-free localization. So the next evolution of Duster was Master. As in robotics, often you need a digital representation of the world. We extended this line of work towards large-scale structure for motion. That's what you see here. And robots are not static objects; they move. So the next evolution of this foundation model family is Muster, which is actually which has memory also, and that allows us also to directly compute the relative pose between cameras. And finally, in this video you will see the latest addition, which is Panster, and that includes semantic segmentation or semantic understanding to the 3D points. So it gives meaning to the 3D points. And that's a very ongoing research line at Naval Labs Europe, and there is much more to come pretty soon. All this merges together to our family of 3D foundation models called Duster. So now we have our robots can understand what the world looks like in 3D, but we also want them to understand what is happening with people around. So we also work on on a foundation model for human understanding. So here, this is a model that does not only detect people, it also reconstructs their meshes in 3D and eventually will understand what those people are doing so that robots can use it. And for this, actually to solve a couple of limitations we saw, we developed our own full body parametric model that supports all ages, genders, and body shapes, all in one model. It's called Any for anybody, and you will be able to play with this demo if you want to tonight during the demo session. So you can do all kinds of funny configurations, even a pregnant male baby if you want to. So now we know how robots will perceive their environment. Now let's talk about how we make them to actually do something in the real world. And for this, I would like to point you to our work on a foundation model for robot navigation. And here you see one of our delivery robots operating at our premises at Naval Labs Europe, and that's exactly what you will see tonight. You will see this robot with these people, and all of you operate like navigating without a map in our cafeteria. And here you see the same robot, the same model running in the same type of robot, but this time at the 1784 building in Korea. And finally, interaction. So here we tackle many challenges, but what I want to show you today is the challenge, or like how we address the challenge of deploying foundation models and deploying AI in robotics. And here I would like to point you to our work called Flow, which is a no-code, low-code framework that we built to make it easy to actually build new robot services. And this is also something you will see in much detail tonight. And here in this video, you see this last service I mentioned earlier, where users at 1784 can send packages like between each other using these robots. And this was launched, for example, at Valentine's Day, so that people can send Valentine chocolate boxes to each other. And again, exactly this you will see tonight, and this service was the first one that was fully built on top of, using Flow, our own robotic service deployment framework. Well, that's it from my side. Welcome again, everybody. I'm really happy that so many are here. I hope we will have an interesting, fun workshop.